Welcome to question number 12 on the worked out example series on trigonometry. The question number 12 is on property of inverse tan function or arctan function. Actually, there are three questions within question number 12. The question number A reads like this. Prove A 4 tan inverse of 1 over 5 minus tan inverse of 1 over 239 equals pi by 4. This is question number A. Question number B. Tan inverse of 1 by 2 plus tan inverse of 1 by 5 plus tan inverse of 1 by 8 equals pi by 4. Then question number C. Tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 equals pi. So these three are the questions which we have to solve or rather prove. And for proving this, I am going to use the property of inverse functions. Let me read out what is the property. The property of inverse function goes like this. F of f inverse of x equals x for every x in the domain of f inverse. F inverse of f of y equals y for every y in the domain of f. Domain of arctan function is are all real numbers and the range of arctan function is open interval minus pi by 2 to pi by 2. So this is a short definition of what is an inverse function and the definition of the arctan function, that is the domain and range of arctan function. I have drawn the Cartesian coordinate plane here. I am going to trace the behavior of arctan function. So this is the arctan curve. The domain is minus infinity to plus infinity and the range is minus pi by 2 to pi by 2. But there are two horizontal asymptotes at minus pi by 2 and pi by 2. That's why arctan function's range is the open interval minus pi by 2 to pi by 2. That is, it reaches asymptotically to minus pi by 2 in the minus y axis and in the x the positive y axis it reaches pi by 2 asymptotically. I am going to employ the behavior of this arctan function in order to solve these. I am going to rub this. We will start from question number A. Okay, let's start with A. The question A is like this. 4 So we have to prove 4 tan inverse of 1 by 5 minus tan inverse of 1 over 239 equals pi by 4. For the starters, I am going to call tan inverse of 1 by 5 as alpha and tan inverse of 1 by 239 as beta. Let alpha equals tan inverse of 1 by 5 and the value of alpha is between minus pi by 2 to pi by 2. Okay. Similarly, let beta equals tan inverse of 1 over 239. And similarly, beta is also between minus pi by 2 to pi by 2. And as per the properties of inverse function, if alpha is tan inverse of 1 by 5, tan alpha must be tan of tan inverse of 1 by 5, which is 1 by 5. Let me write that down. So tan alpha equals tan of tan inverse of 1 by 5, which is equal to 1 by 5. Similarly, tan beta equals tan of tan inverse of 1 over 239 equals 1 over 239. Okay, now if I substitute tan inverse of 1 by 5 as alpha and tan inverse of 1 over 239 as beta, the question becomes, we have to prove rather 4 alpha minus beta equals pi by 4, right? So we have to prove 4 alpha minus beta equals pi by 4. This is what we have to prove. Now let's do a small consistency check. Because we have said that alpha is between minus pi by 2 to pi by 2 and beta is between minus pi by 2 to pi by 2. Therefore, 4 alpha minus beta should be Therefore, 4 alpha minus beta should be between minus 4 by 2 plus pi by 2. Why plus pi by 2? I have a minus beta here. So this will become minus or minus pi by 2 plus pi by 2. Between 4 pi by 2 plus pi by 2, this will give me, so this is minus 3 pi by 2, right? So 4 alpha minus beta should be between minus 3 pi by 2 to 4 pi by 2 minus pi by 2, 3 pi by 2. So this will give me plus 3 pi by 2. Okay, 4 alpha minus beta should lie between minus 3 pi by 2 and plus 3 pi by 2. And the required answer is pi by 4. And pi by 4 is definitely within this interval. So our required expression, that is the question number A, 4 tan inverse of 1 by 5 minus tan inverse of 1 over 239 equals pi by 4 meets this consistency check. So let's go ahead and prove it. Okay, let's get into the main proof. What we have to prove is, we have to prove 4 alpha minus beta equals pi by 4, where alpha equals tan inverse of 1 over 5, comma, beta equals tan inverse of 1 over 239. We also know that tan alpha equals 1 by 5 and tan beta is 1 over 239. Okay, let's start. So we have 4 alpha minus beta equals pi by 4. Okay, let me take tan both sides. So take tan both sides, then we have tan 4 alpha minus beta equals tan pi by 4. Tan pi by 4 is a known value. Tan pi by 4 is 1, right? So this equals 1. Therefore, what we have to prove is tan 4 alpha minus beta equals 1. Let's start with LHS. So what we have in LHS? LHS we have tan 4 alpha minus beta. Okay? And I'm going to use the tan A minus B formula. So I have written tan 4 alpha minus beta in this form using the tan A minus B formula. Now I have tan 4 alpha. I need to evaluate what is tan 4 alpha, because tan beta is pretty straightforward. Tan beta is 1 over 239, no problem. But I need to calculate tan 4 alpha. Let me call this as equation number 1, because we will calculate tan 4 alpha and substitute in equation number 1. So let me go to tan 4 alpha. Now tan 4 alpha can be written as tan 2 alpha plus 2 alpha, that is, right? And I can use tan A plus B formula here. Okay, so I have just used tan A plus B formula here. I could have straight away written it as 2 times tan 2 alpha divided by 1 minus tan square 2 alpha, but I just wanted to go step by step. So this we can write it as 2 times tan 2 alpha divided by 1 minus tan square 2 alpha, right? Now let us calculate what is tan 2 alpha. Tan 2 alpha I can write it as tan alpha plus alpha, right? And I can use again tan A plus B formula. So we will have tan alpha plus tan alpha divided by 1 minus tan alpha, which is 2 tan alpha divided by 1 minus tan square alpha. Okay, now let us substitute the tan alpha value here. Tan alpha is 1 over 5, right? So 2 multiplied by 1 over 5 divided by 1 minus 1 over 5 whole square. Okay, so let us simplify this. So this will give me 2 by 5 divided by, this is 1 over 25. Take 25 as common denominator. So 25 minus 1, 24, 24 divided by 25. So this would be 2 divided by 5 multiplied by the reciprocal of this, 25 divided by 24. Let's simplify this. So this will go 5 times. So this will be 12. So this will be 5 divided by 12. Okay, let us substitute tan 2 alpha equals 5 by 12 in this. So this will give me, let us take it to here. So tan 4 alpha would be 2 times tan 2 alpha, that is 2 times 5 by 12 divided by 1 minus tan square 2 alpha, that is 1 minus 5 square by 12 square, right? So 2 multiplied by 5 by 12, so this will go 6 times. Then 12 square, 144. So 144 common denominator, 144 minus 25, that would be 119. So we just have to simplify this now. So we have 5 multiplied by 24 divided by 119. So it will be 5 24s are 120. So 120 by 119. So tan 4 alpha is 120 divided by 119. Then we will have our final answer. Let me call this as 2. Substitute 2 in 1. 2 in 1. Okay, so we are in the home run now. So we have tan 4 alpha minus beta equals tan 4 alpha is 120 divided by 119. So 120 divided by 119 minus tan beta is 1 over 239. The whole thing divided by 1 plus tan 4 alpha, again 120 divided by 119 multiplied by tan beta 1 over 239. Remember, we have to prove that this equals 1 because this equals tan pi by 4, which equals 1. So this should be 1. Okay, are we seeing 1 here? I don't see 1 here. Let's see. So this equals, let me take 119 multiplied by 239 as the common denominator. So we have 120 multiplied by 239 minus 1 multiplied by 119. The whole thing. Again here 119 multiplied by 239 as the common denominator. Okay, so we have this. So we can cancel 119 multiplied by 239 on both sides, in both numerator and denominator. So we are left with 120 multiplied by 239 minus 119 divided by 119 multiplied by 239 plus 120. So this should be equals 1. Let's see. Now, can I write 119 as 120 minus 1? Because it is one and the same. 119 is 120 minus 1. So let's write it as. Now let me remove this bracket and multiply 239 inside throughout. So I have minus. We have minus 239 plus 120, which is minus 119. So these two get cancelled, equals 1. So that's the proof. Let's go to question number B. Let's get to question B. Question B is like this. Tan inverse of 1 by 2 plus tan inverse of 1 by 5 plus tan inverse of 1 by 8 equals pi by 4. Okay, just like question number A, we are going to take tan inverse of 1 by 2 as alpha, this as beta, and this guy as gamma. So let tan inverse of 1 by 2 equals alpha, which implies tan alpha equals tan of tan inverse of 1 by 2, which is 1 by 2. Similarly, tan inverse of 1 by 5 equals beta, which implies tan beta equals 1 by 5. Just like this. Then tan inverse of 1 by 8 as gamma, which implies tan gamma equals 1 by 8. So just as question number 8, we have to prove alpha plus beta plus gamma equals pi by 4. So therefore alpha plus beta plus equals pi divided by 4. Just as before, let us take tan both sides. So this is tan of alpha plus beta plus gamma equals tan pi by 4, and tan pi by 4 is 1. So we have to prove tan alpha plus beta plus gamma equals 1. I am going to use tan a plus b formula here. How? I am going to group tan alpha plus beta together and gamma as separate. So alpha plus beta will be a, gamma will be b, and work out. So our LHS, I am going to write it as tan. Okay, so this is a, this is b. I am going to use tan a plus b formula. So this will be tan, okay, tan alpha plus beta plus tan gamma divided by 1 minus tan alpha plus beta tan gamma. Okay, now again tan alpha plus beta, we can use the tan a plus b formula and simplify this further. So this will give me, okay, now we can directly plug in the tan alpha, tan beta, tan gamma values here and simplify. Or I can take 1 minus tan alpha minus beta as common denominator here. Similarly here in the process, 1 minus tan alpha, tan beta will get cancelled in both numerator and denominator. We can do either. Let us directly substitute the values. So tan alpha is 1 over 2. So 1 by 2 plus tan beta is 1 by 5 plus tan gamma is 1 divided by 8. Okay, now it's a fairly simple algebra to complete. I'm going to take 10 as common denominator for this term and write this as 7 divided by 10. 1 minus 1 divided by 10. Again 10 common denominator. 10 minus 1, 9. So this will be 9 by 10. Whole thing plus 1 by 8. Similarly here 1 minus this again 7 divided by 10 divided by 1 minus 1 divided by 10. So this will be 10 common denominator. 10 minus 1, 9 by 10. So let's do the operations. Okay, simple. Now I can cancel 10 here. Similarly I can cancel 10 here. Then let's simplify this. I have 7 by 9 plus 1 by 8. Okay, so 72 common denominator. So you have 56 plus 9. So this equals 1. So hence prove. Quad era demonstrandum. It's proved. So let's go to question number C. But I'm going to leave question number C as a small exercise for you to work out in exactly the same manner. Very simple. You can try yourself. Thank you. Let's go to question number 13 then.